We're going to be doing some differentiation, and we're going to start with something easy. So let's say that we have the function f of x is equal to some constant, and we'll say 5. And we're asked to find, and I'm not going to write this out every time, but we want to find f prime of x. So what we're going to do is we're going to use what's called the constant rule. So we're going to say f prime of x is equal to, now 5 is a constant, and the derivative of 5 is 0. So we're going to be focusing on strictly the mechanics of finding the derivative of these functions. So there's a geometric argument. If you were to graph this function out and look at the slope of the tangent line at any given point on this graph, and you'll see that the slope is 0. Okay, so we're just going to be looking at the functions and taking derivatives of them, and that's pretty much what we're going to do. I'm not going to display any graphs and look at it geometrically, okay? Alright, so this is known as the constant rule. We have the derivative of the constant. Okay, well, let's move right on here and look at some more examples. Let's say that, for example, we had y and it was equal to 7. Okay, and we are asked to find dy over dx. Okay, this notation here is the same thing. We're going to take the derivative of this guy. It's just different notation. Alright, so we would say dy. Now we notice that there's no x over here. Okay, there's not an x. This says with respect to x, but there's not an x. But I'm going to write dy over dx is equal to 0. So the derivative of a constant is 0. So I'm going to go through several different ways that we can ask this using a different notation here. If we were to ask to find y prime, okay, this would be the same thing. We could say y prime also is equal to 0. Okay, so there's different ways of asking how to find the derivative of a function. Okay, that really was an equation there, but anyway, we won't get into all that. If I have, for example, f of x is equal to x plus 1, and I'm asked to find f prime of x. Okay, this time we're going to add another rule to this. So we know this is a constant here, and when we take the derivative of a constant, we get 0. But what we don't know is how do we take the derivative of x? Well, there's a 1 up here in the power, okay, but it's not written out. This is known as the power rule. You take the 1, bring it out front, take whatever's up here in the power, bring it out front, rewrite, and then if I subtract 1 from this up here, this power, I get, well, I'll just write it out longhand here. F prime of x is equal to, okay, so I subtracted 1 from the power, and we need to rewrite this. This is going to be 1 times x to the 0, but anything raised to the 0, okay, is going to be 1, and 1 times 1 is 1. So as we can see here that the derivative of our original f of x, the derivative of x plus 1, is 1. If I had f of x is equal to x squared, and we wanted to find f prime of x, we say f prime of x is equal to, we take the 2 out front, and there we go, subtracting 1 from the exponent. Let's look at this more generally. Let's say that I have, we'll call it g this time, g of x is equal to a, some number a times x to the n. And we're looking at the power rule. So we want to take the derivative, we want to find g prime of x, so we say g prime of x is equal to, now I'm going to take whatever this is and bring it out front, and subtract 1 from it. Okay, so this is the generalization here of the power rule. Alright, let's look at another one. Now I'm going to introduce some more notation. Let's say we were asked to do this. Okay, what this note operator says, it says, listen, we want to take the derivative of x cubed with respect to x here. So there may be more than one variable in here. Maybe x, there may be an x and a y, but this one here says, let's take the derivative of x cubed with respect to x. And so what's the derivative of x cubed? You take the 3, bring it out front, and subtract 1 from the exponent. So let's look at some of the notation. If we were given an f and we wanted to find f prime, or maybe we had some equation like this, right, and we were asked to find y prime, or it could be an operator like this here. Okay, so different ways of asking for find the derivative. Alright, let's get through and get working some examples here. Let's say that, okay, and we'll call it something else this time. We have 4x squared plus x plus 1, and we want to find h prime of x. So that means we want to find the derivative. Well, the first one we're going to use the power rule. Take the 2, bring it out front, and 2 times 4 is 8. Subtract 1 from the exponent. Now I'm not going to put a 1 here, just leave it alone. The derivative of x, there's a 1 up here. Remember, we bring it out front, and then subtract 1 from the exponent, and that gives us a 0, but x to the 0 is left with 1. So the derivative of x is just 1. And then we have a constant here, and the derivative of constant 0. So we have the derivative of h of x is h prime of x is equal to 8 times x plus 1. Moving right along. Alright, let's say we were asked, we're going to use this notation this time. To the third minus, let's say 4x squared. Alright, so we're going to take the derivative with respect to x. So 3 times 3 is 9. Subtracting 1 from the exponent. And 2 times 4 is 8. So there's our derivative. 9x squared minus 8x. We have y is equal to 2x, use something different here. Okay, and we want to find, we're asked to find y prime. So that means we're going to say y prime, we're going to take the derivative, take the half, bring it out front, subtract 1, gives us a negative half, and the derivative constant is 0. Let's now simplify this down. So a half times 2 is 1. And that's what we're left with. We could also rewrite this with positive exponents. We would take that down into the numerator because it is a negative. Alright. I think we'll add another rule. Alright, we're going to learn a new rule And this one's called the chain rule. So the best thing to do is just take a look at an example. Let's call this function s. Why not? And we'll say we're going to, let's see, x plus 1 to the third power. Okay, so this is known as the chain rule. And so we're asked to find s prime of x. We want to find the derivative of this. So s prime of x is equal to, now this is how the chain rule goes. It's like the power rule, except there's an extension to it. You take this 3, bring it out front, just like in the power rule, except this time we rewrite everything in parentheses. Subtract 1 from the exponent, just like the power rule. And then this time we're going to take whatever's in parentheses and chain it out. Okay, so we're going to take the derivative of this and put that derivative right here. So that's really the only difference. It's known as the general power rule. So the derivative of x is 1 and the derivative of 1 is 0, so we're just left with a 1 here. And of course, we're just going to rewrite this. And this is s prime of x. So that is the power rule, or the general power rule. This is also known as the chain rule. Let's look at another example, of course. Let's say we had y is equal to 7 times x squared plus 1, and it's raised to, let's say, the 7th power. And we're asked to find y prime. Okay, so we're going to take the 7, bring it out front, and 7 times 7 is 49. Rewrite everything in parentheses. Subtract 1 from the 7, you get a 6, and take the derivative of the inside and bring it out right over here. So the derivative of x squared, remember, is 2x, and the derivative of 1 is 0. Now we want to simplify this down. So let's go ahead and take our coefficients. Let's take this 2x and bring it over here. So we have 2 times 49 is going to be 98 x. Alright, we're going to rewrite what's in parentheses. We have x squared plus 1 raised to the 6th power. And of course, don't want to forget that y prime. Let's look at another one. Alright, let's see. We have y is equal to 10. Let's see, and in parentheses I'm going to have x squared plus 2x plus 1, close parentheses, raised to the 4th. Okay, so we take the 4, bring it out front, and 4 times 10 is 40. Rewrite everything in parentheses. Subtract 1 from the exponent, that gives us a 3, and take the derivative of the inside and bring it out. And I'm going to start a parentheses here, so this is x squared. Ooh, taking the derivative. 2 times x plus 2. Okay. And that's y prime. Now we could factor this 2 out if we wanted it and made that an 80, but I'm just going to leave it like it is right here. Alright, so this is the chain rule, also sometimes known as the general power rule. Okay, so we've got the constant rule, the power rule, and the chain rule under our belt. Is it time to learn a new rule? Maybe. Alright, I said it's time to learn a new rule. So let's take a look at it. This one is going to be known as the product rule. So if we had, let's say we had something that looks like this. G of x is equal to x times x squared plus 1, and it's raised to the third power. Now, the rules that we've learned so far, we're not going to be able to use those techniques in order to take the derivative of this. Now, let me just say something here real quick. Because this x squared plus 1 is raised to the third power, that's x squared plus 1 times x squared plus 1 times x squared plus 1. Yeah, you could multiply all this stuff out and get one big large polynomial, and then take the derivative of it. You'd know how to do that, but you might be there half the day doing that. So instead, we're going to learn a technique for taking the derivative of this guy right here. Okay, this technique is known as the product rule. Okay, the product rule. So this is how the product rule goes. Now, there's two different ways of doing this, but I like to do it this way. It's not going to matter because in the end we get the same result. I take the derivative of the first function here, and this guy right here. And I'm going to take the derivative of x, and derivative of x is 1. Right? And then rewrite the second function, x squared plus 1 raised to the third power, plus, alright, then I rewrite my x, and now I'm going to take the derivative of this one here. So this one, remember, so we take the derivative of this guy right here, we take the 3, bring it out front, rewrite everything in parentheses, subtract 1 from the exponent, you get 2, and then we do the chain part. We take the derivative of the inside of what's in parentheses and bring it out. So the derivative of x squared plus 1 is 2x, right? Derivative of x squared is 2x. And then, of course, we want to kind of rewrite this, clean this up. We have x squared plus 1 raised to the third power plus, what can we do here? I'm going to take this 2x and bring it out front. So that's going to be 2 times 3 is 6. And this is x squared. And rewriting the rest here. And I'm going to leave it just like this. However, you may be asked to factor this completely down, and I'm not going to get into that. We're just focusing on the calculus, focusing in on these rules before we get caught up in the intermediate algebra. Okay, let's look at another one. Actually, I think what I'm going to do is I'm going to write out this rule. So this is just the general rule here for the product rule. We have g of x, some function g of x, times some function h of x. It's like in the last problem we had the x here, and then what was in parentheses raised to whatever that power was, to the third power. Now we're taking the derivative, so this becomes f prime of x is equal to, take the derivative of the first, so I say g prime of x times h of x plus, rewrite the first function, times the derivative of the second function. Right, and this is known as the product rule. The product rule. The product rule. It's a pretty easy rule. Alright. Alright, product rule. Let's see. Let's work another example of the product rule. Okay, let's say that we had k of x is equal to x plus 1 squared times x minus 1 squared. And we are asked to find the derivative. So we're going to use the product. So I'm going to take the derivative of the first function here. Take the derivative of this. And so that means we're going to be using the chain rule. So I'm going to take the 2, bring it out front, rewrite everything in parentheses, subtracting 1 from this exponent, and then I'm going to rewrite the second function, plus rewrite the first, and now taking the derivative of the second function. So take the 2, bring it out front, subtracting 1 from the exponent, and then taking the derivative of what's inside, chaining it out as 1. I think I might have left that off here, but it doesn't matter because the derivative of the inside of the parentheses here is just 1. Now I'm going to go ahead and just kind of rewrite this. And I'm going to take this 2 out front. Now you may be asked to factor this guy, and I'm not going to really get into that right now. Okay, we're just focusing on these rules that we're learning. Okay, let's look at another one. No, actually, I have decided to look at another rule. This will be your last rule that you'll have to learn on differentiation. We want to take the derivative of 1 over x. And how are we going to do that? Well, we could rewrite this as f of x is equal to x to the negative 1, and then we could take the derivative of this, take the negative 1 out front, subtract 1 from the exponent, gives us a negative 2, and if we rewrite this, we get negative 1 over x squared. Of course, we'd bring this negative out here in the front, but that's okay. So this would be the derivative of f of x. However, there is another way of doing this, and it's known as using the quotient rule. The quotient rule. And this is how it goes. I'm going to take the derivative of the top, which is 0, times the bottom, minus the top times the derivative of the denominator, which is 1, and it's all over the denominator squared. Yes, that is the quotient rule, and when you simplify this in the top, whoa, and we end up with the same thing as f prime of x. So it may be faster going this route, okay, to find the derivative than using the quotient rule. However, you'll see here in just a minute that we're going to need to do it this way, use the quotient rule, where you can't do it any other way but using the quotient rule. Let me write this quotient rule out, the general rule. So this is known as, let's spell it out here for you, the quotient rule. Okay, this is how the quotient rule goes. We're given some function f of x. We have a function in the top called h of x, then a function in the denominator, we'll call it g of x, So we want to find f prime of x. So we take the derivative of the numerator, and the derivative of h of x is h prime of x times the derivative, or times the denominator, minus the numerator times the derivative of the denominator. Sorry if you're hearing some background noise. That's a noisy sister of mine, and I mean noisy. G of x, and I'm going to put brackets around this set of parentheses, but then you just take the denominator and you square it. Alright, so this is it. This is the general rule. This is what you need to keep in mind right here. Okay, so let's work another one. So let's say that we have, I'll use some different letters this time. Let's say we'll use t. Alright, the function, we'll call it s, and we have 10 over x squared. So yes, you could take this x squared into the top and use the power rule, but we're going to use the quotient rule on this. So we're going to take the derivative. First I'm going to write this, s prime of t. I see a mistake I made here. So used to using x's. That should be a t right there. Okay, sorry about that. So the derivative of the numerator, so derivative of 10 is 0, times the denominator, minus the numerator, times the derivative of the denominator, which is 2t, and it's all over the denominator squared. And of course we want to clean this up, right? So we say s prime of t is equal to, so 0 times t squared is 0. We have, I'm going to take this negative out front. We have 2 times 10, that's 20 t. That's all over. Now I'm going to go ahead. We have t squared raised to the second power, so we multiply powers. So that becomes t to the fourth. And of course, by examining this, we can actually simplify this down. It looks to me like, because we have a t up here in the numerator and 4 of them down here in the denominator, we could simplify that down to 20 over, whoops, I need to get rid of that. There was 1 up here, 4 down here, so this becomes negative 20 over t to the third. Good enough. Okay, we're still going to be working some problems here, demonstrating the quotient rule. So we have k of x is equal to x plus 1 over x minus 1. Alright, so we want to find k prime of x is equal to. So we want to find k prime of x. So we take the derivative of the numerator, and the derivative of x plus 1, you should know now, is just 1, right? Derivative of x is 1, derivative of 1 is 0. You rewrite the denominator, minus, now write the numerator, times the derivative of the denominator, and derivative of x minus 1 is 1. And that's all over the denominator squared, x minus 1 quantity squared. Now let's go ahead and simplify this down a little bit. So we have k prime of x is equal to, so 1 times x minus 1 is just x minus 1, and then I'm going to distribute this minus through, so this becomes minus x minus 1. And of course, we don't even pay attention to that. And now we want to go ahead and simplify the top. We have an x and then we have a minus x, so those are going to cancel out. We have a minus 1 and a minus 1, so that becomes a minus 2 over x minus 1 squared, and this is k prime of x. And of course we can take this negative here and actually bring it out in front of the fraction bar. Alright, let's look at another one here. We got s of x is equal to 6 times x squared plus 1 quantity squared, and that's going to be all over x squared minus 1. And we want to find s prime of x. So we take the derivative of the numerator first. That means we're going to have to take this 2, bring it out front, and 2 times 6 is 12. Rewriting everything that's in parentheses, subtracting 1 from the power, so that just gives us a 1 there, so we're not going to write anything. And then times the denominator, a minus, okay, now we're going to, I see a mistake I might have made, or something I forgot to do. We need to take the derivative of what's in parentheses here. Okay, so we don't want to forget that. I went ahead and rewrote the bottom right here, but we need to take the derivative of what's inside, and derivative of x squared plus 1 is going to be 2x, because the derivative of x squared is 2x. And I'm going to write that right here. So 2x. I'm going to squeeze it in right there. Alright, minus, I'm going to have to continue this down here. Okay. We're going to rewrite the top. Times, and then the derivative of the denominator, which is 2x. So let's clean this up. Oops, about forgot again. We want to square the bottom. X squared minus 1, right, all quantity squared. Okay, that looks like a mess. That is a mess. We need to clean this up. Alright, so we need to clean up this mess, because that's about what we got here. So I'm going to rewrite s prime of x is equal to, okay, I'm going to go ahead and take this 2x and bring it out, and let's see here, bring it out front. So 2 times 12 is 24 x, and we have x squared plus 1 times x squared minus 1, which was in the denominator, and then we have this minus here, and 6 times 2 is 12, so I'm going to bring that out, 12x out front, and then rewrite x squared plus 1 and the quantity squared, and that's all over x squared minus 1, and remember we have to square the denominator. Alright, so hopefully everything is correct there. Okay, and I didn't make any mistakes. Alright, well, so much for all the rules. So we learned the constant rule. We learned the power rule. We learned the chain rule. We learned the product rule. And we learned the quotient rule. So these are all our basic rules here that you need to know when it comes to taking the derivative. Now let's just let's actually go back up here. Let's clear that off, and let's look at another one here before we go. Let's say I had d of x is equal to the square root of x cubed plus 2x plus 1, and we're asked to find d prime of x. Well, the first thing we're going to have to do is rewrite this, and that is we're going to write it as x cubed plus 2x plus 1, and it's all raised to the half power. Okay, so we get this out of radical form, get an exponential form, and now we want to take the derivative. So we take the half out front, we rewrite everything in parentheses, subtracting 1 from the exponent, and you get a negative a half. Right, a half minus 1 is a negative a half, and then we rewrite or take the derivative of what's in parentheses, 3x squared plus 2, right? And I'm now going to clean this all up. So this becomes 3x squared plus 2 over 2, and then I'm going to put it back into radical form, x cubed plus 2x plus 1, and that is our d prime of x. So just a little bit of review there. Well, how would you like to take the derivative of that? Okay, I think the next section is going to be on trig functions.